Hello everyone, we are from Group Techie and this is our presentation for HPDP project. So our presentation is in two parts for case study 1 and also case study 2. First, meet our team members. We have Zul Hakim, Tongming, Azim and Saharul. So for case study 1, which is the University Academic Relational Database System, and the presentation outline is the project proposal, database design and implementation. So the situation is we are the junior DBA required to design university system to fulfill the stakeholders' requirement. So we begin by creating the ERD from the coursework requirement obtained by inquiring the staff, and we finalize the requirement, then we can generate the ERD to suit the requirement. Next is the architecture, we chose is the enterprise DBMS for its scalability and high performance, and the supporting of a very large database and also the multi-processing support. And next is the selection of RDBMS and services, which is the MySQL and Amazon Aurora. So MySQL is an open source, so it results in lowering the licensing and the maintenance cost, and it also have low total cost of ownership with high return of investment. So the Amazon Aurora is MySQL compatible and up to 5 times the throughput speed compared to traditional MySQL database, and it also supports automation of services by Amazon RDS and continuous backup to Amazon S3.
For our database, we have considered Amazon S3 to be used in our system. Objects like reports and records of courses and students need to be stored for years with high reliability. The file system should also support complex query for analysis purposes to help improve cost efficiency. Other than that, Amazon Aurora works really well with Amazon S3 in many ways. Then we also have chosen to implement indexes in our system to facilitate the high transaction needs of our users. There are advantages like increase in query performance, reducing the table space, but there are also disadvantages of using indexes. But to overcome or lessen the effect of indexes, there are some improvements that we can do, such as remove indexes that are no longer needed, sort the indexes, prioritizing cluster indexes above non-cluster indexes. Then, considering our requirements, the system doesn't involve high volume transaction at all times. Hence, we think it is adequate to use a DB-T3 large instance of our system without getting overkill with the performance while still maintaining and delivering the required performance.
When migrating the database to Amazon Aurora, there are two options available, which are physical and logical migration. In this case, we choose physical migration. Physical migration is overall faster, especially involving large databases such as ours with 5 million records. It also does not suffer in terms of performance when backups are taken, which is important to ensure that the data we have is stored and secured. Other than that, physical migration can migrate the source database, which helps to ease with complex components which are present in the original database. In terms of data security, AWS security uses a shared responsibility model. The actual security of the infrastructure of AWS is secured and the sole responsibility of Amazon at their own physical locations. While the security in the cloud is mostly our responsibility to maintain and organize, following our organization structure and regulations, which we should run the database on a virtual private cloud, control access and resources of the staff, students, and departments using AWS identity and access management policies. We should also use security groups to control the IP that is allowed to access the database for more sensitive information like addressing or banking information. Finally, we should use Amazon Aurora encryption to secure database clusters and snapshots for backup purposes.
Database should have optimal performance because a poorly performing system can degrade the performance. To manage performance, we focus on 4 aspects. For storage scaling, Aurora Storage automatically scales with the data in your cluster volume. For instance scaling, we alter the database instance class for each database instance in the database cluster to grow our Aurora database cluster as needed. Next, to achieve read scaling, we can create up to 15 Aurora replicas in a database cluster that uses single master replication. And to manage connections, we recommend utilizing Amazon Relational Database Service (RDS) proxy if your applications often start and shut connections. Next, besides database performance, recoverability should also be emphasized. Aurora backs up cluster volumes automatically and retains restore data for the length of the backup retention period. No performance impact or interruption of database service will occur as backup data is being returned. To recover data, we can create a new Aurora database cluster from the backup data that Aurora retains. That is all for case study 1.
Moving on to case study number 2, where we discuss about implementing a distributed database system on multi-site company. So, we will be covering the project proposal, infrastructure of types of database design consideration, backup and recovery, and optimization. So, the subject of our case study is a pharmaceutical company which has a multi-site office. We need to facilitate the migration of the company current system to a distributed database system that facilitates 5 offices that mirror each other. So we start by analyzing different type of database. By comparing the infrastructure of centralized and distributed database, we know there are pros and cons of both database type. Despite the disadvantages of distributed database system, the advantages still outweigh its counterpart due to the fact that we want our system to be more scalable as the business grows, high accessibility, while still maintaining its data and security at the top level.
Next is the database design consideration, which consists of data fragmentation, allocation, and replication. So fragmentation is the process of splitting the database structure into smaller pieces, resulting in reduced amount of data to be transported later. Then, after we have done fragmentation, we allocate the fragmented data to each site that we have. And lastly is the data replication. Is done to keep the numerous copy of data in each site. And in this case, we chose partial replication, which each site has several copies of the fragmented data, but not all of them.
Now, we are going to talk about backup and recovery strategies. For backup strategies, we are going to duplicate the dataset. The redundancy set includes a replica of the online redo log files, the current control file, and the most recent backup of data files, among other things. For the recovery strategy, we have 3 to talk about: undo, redo, and checkpoint. Undo or rollback is in the event of soft failure that results in database inconsistency. In rare cases, we might have to do transaction redo, which is used to revert to a consistent state in our database. Or checkpoint is used for when complete database failure and we need to redo anything that's been failed.
Now we look at the optimization of database. To optimize database in a distributed database system, query processing ensures that data is handled at multiple locations, minimizing resource consumption at the same time. Processing a query includes optimization at both the global and local levels, and to fully optimize resource utilization, operation shipping, data shipping, and hybrid shipping approaches can be taken. Finally, a distributed system requires more security measures than a centralized system. To counter threats, control measures such as access control, flow control, and data encryption are used. On the other hand, to stop intruder attacks, security measures such as communication security, data security such as authentication and authorization, and data auditing by examining audit logs can be done. So that's all for our presentation. Thank you.